Okay, so we're going to start looking at this equation over here, and then we'll apply it to the congruency. So in a normal algebraic way, we would take, in order to solve this, subtract 3 from each side, so we would get 5x is equal to a negative 3. And then we would divide this x by 5, which would then make us divide the negative 3 by 5 to get that x is equal to a negative 3 over 5. We would then plug this back into here, and if we said this, it would be 5 times a negative 3/5 plus 3 is equal to 0. So this is the solution that will make this side of the equation equal to this side. So now applying this, what we have over here, onto here, we would take 5x plus 3 is congruent to 0 in mod 6 and subtract 3 from each side. That would leave us with 5x is congruent to a negative 3. But instead of doing all of this right here, we got x by itself, we are going to find the multiples of 5. So we're going to count by 5, so 5, 10, 15, 20, 25, 30, 35. So then, these are the numbers that are equivalent with a mod 6. So we didn't have to adjust 5 because it's within the mod, but we did have to adjust 10. So we took 10 minus 6, which gave us 4. Then we took 15 and subtract 2 of these mods, so that's 12. So 15 minus 12, which is equal to 3. And look at here, this 3 appeared within our sequence, which means that there is a solution because we want it to be congruent to 3. So we know that this multiple of 5 will work within this congruency. Therefore, there is a solution. On to our next example, we have 2x plus 4 is congruent to 0 in mod 11. So for the same way that we did it up here, we're going to subtract our 4. So we are left with, from each side, so we are left with 2x is congruent to negative 4. So we're going to find the multiples of this 2. And those are 2, 4, 6, 8, 10, 12. But we need to make them into mod 11. So 2 is fine, 4 is fine, 6 is fine, 8 is fine, 10 is fine, but 12 is not. So we're going to take out a group of 11, which will give us 1. However, we didn't really need to go this far because we found that 4 is within the multiples of 2. Therefore, this could be plugged in here to make this congruency work. So there is a solution. Now on to this example, we have 6x plus 1 is congruent to 4 in mod 8. So as we did before, we're going to take 1 away from each side, which will leave us with 6. 6x is congruent to 3 in mod 8. So we're going to take, this should be multiples of 6, but the multiples of 6 would be 6, 12, 18, 24, 30, 36, 42, and 48. So we're going to go through and simplify them so that they are in mod 8, because we can't have anything exceeding mod 8, so over the number of 8. So we have 6, then this 12 becomes a 4, 18 becomes a 2, 24 becomes a 0, 30 becomes a 6, 36 becomes a 4, and 42 becomes a 4, and 48 becomes a 0. Because we're taking out groups of 8, as many as possible. And as we can see, there is no circle here, indicating that there's no 3 within this sequence. Therefore, there is no solution. I also would like to note that we didn't have to continue because this 0 showed up. So that indicates that we're going to repeat the pattern once a 0 appears. But this was the amount of that I chose to go through. So this one has no solution.